Okay, to review, the third type of segment in the triangle, which is actually the first one we talked about in section 1, is the perpendicular bisector of the sides. If I have triangle ABC, I can construct the perpendicular bisector of the sides by using my tool that constructs the perpendicular bisectors. And I'll click on each segment one at a time, and I'll construct the perpendicular bisectors. So notice that, as we looked at before, these perpendicular bisectors are different from the other three segments we've talked about in that they may not actually go through the vertices of the triangle. They go through the midpoints of the opposite sides. So these points where they intersect the sides are the midpoint. So here point D is the midpoint of segment AB. So segment AD and segment DB are congruent to each other. The same here for this point, which we'll call E. Segment CE is congruent to EB. And here's the midpoint of that side. So CF is congruent to FE. And those three intersect at this point here, which we called the circumcenter of the triangle. And the special property of the circumcenter that we discussed is that the circumcenter was exactly the same distance from the three vertices of the triangle. The distance from point G to point C is the same as the distance from point G to point B, and the same as the distance from point G to point A. So it is the same distance from all three sides. Another way to say that is that the segment GC, segment GB, and segment GA are all congruent segments. This point is called the circumcenter because it is the center of a triangle that we can construct that goes that has G as the center and goes through all three vertices of the triangle to circumscribe the triangle. So we've just constructed a circumscribing circle to this triangle. And we noted that the circumcenter may not always be on the inside of a triangle. If the triangle is obtuse, the circumcenter is actually on the outside of the triangle. But the same thing is always true. The distance from that circumcenter to each of the three vertices remains the same. Okay, so the perpendicular bisectors give us the circumcenter, the intersection points of the three perpendicular bisectors, point D in this diagram. That circumcenter is equidistant from the vertices of the triangle, and it's the center of the circle containing the vertices of the triangle, circumscribing the triangle. And for an obtuse triangle, the circumcenter is at the exterior of the triangle.